Welcome to Daily Papers, the podcast where we break down fascinating new research papers into something you can actually understand.
Today, we're looking at how artificial intelligence sees the world, specifically how it describes what it sees. If you show an AI a picture of a park, it might say, "A dog is catching a frisbee in a park." That's great, but what if you want to know about everything else? The person on the bench, the kids on the swings, the cyclist in the background.
Exactly. Getting an AI to describe multiple specific things in a single image is a huge challenge. The traditional way of doing it is, to put it simply, very slow. And today's paper introduces a much faster way to do it.
The paper is called PerceptionDLM, Parallel Region Perception with Multimodal Diffusion Language Models, and it comes from researchers at Peking University and ByteDance.
All right, let's start with the old, slow way. Most of these AI models that understand both images and text are what we call autoregressive. It's a fancy word, but the idea is simple. Think about how you write a sentence. You think of the first word, then the second based on the first, the third based on the second, and so on.
You build it up piece by piece, sequentially. That's how these AI models work. So if you ask it to describe the person on the bench, it generates a description one word at a time. A man is sitting. And when it's done with that, you have to ask it again for the next thing. Okay, now describe the kids on the swings. And it starts over, word by word.
It's like having a painter who will only paint one object in a scene at a time. They meticulously paint the entire dog, then clean their brushes, and then start on the frisbee. If you have 5 or 6 things you want described, you're going to be waiting a while. This sequential process is the bottleneck.
So the researchers behind PerceptionDLM asked, what if we could describe everything at once? And to do that, they turned to a completely different type of AI model, a diffusion model.
Diffusion models are really cool. They become famous for generating those incredible AI art images. But instead of starting with a blank canvas, they start with a canvas full of random noise, like TV static.
Then, step by step, they refine that noise, cleaning it up until a clear, coherent image emerges.
The authors of this paper applied that same logic to text. Instead of starting with noise, they start with a sentence full of blank slots, or mask tokens. It looks like, a man is mask, a mask, polo mask. Then, in a series of steps, the model fills in all those blanks simultaneously, refining the entire sentence together until it makes perfect sense.
And here is the magic trick. This process is inherently parallel. It's not working on one word at a time, it's working on the whole sentence, or even multiple sentences all at once. So if you highlight the person, the swings, and the cyclist in that park photo, PerceptionDLM starts with 3 blank captions.
Then, like a team of painters all working on different parts of the same canvas, it starts filling in the details for all 3 descriptions at the same time. After a few refinement steps, you get 3 complete captions, generated in roughly the same amount of time it would take an old model to generate just one.
Now, the obvious question is, how does the AI not get confused? If it's describing a man in a red jacket and a blue car right next to him, what stops it from saying the man is wearing a blue jacket? This is a real problem called attribute entanglement.
It's a great question, and the researchers have a clever solution called a structured attention mask. It sounds complicated, but you can think of it like putting blinders on the AI.
When the model is writing the description for the man in the red jacket, the mask blocks it from looking at the super specific details of the blue car. It can still see the whole image for general context, it knows the car is there, but it's forced to ignore the car's features when describing the man, and vice versa.
This prevents what the paper calls cross-region hallucination. It keeps the details in the right lane, ensuring the caption for one object doesn't get contaminated by details from its neighbor. It's a simple but powerful idea that allows for clean, parallel generation.
So, does it actually work? Well, to prove it, the researchers had to create a new test, which they call PerceptionDLM Bench. This benchmark is specifically designed to measure both the quality and the speed of describing multiple regions in an image.
And the results are pretty striking. The paper has these graphs showing that as you increase the number of regions you want to describe, the time it takes the old autoregressive models goes up in a straight line. More objects means more time. But for PerceptionDLM, the line is almost flat. Describing 5 objects takes roughly the same amount of time as describing 2.
In their tests, they achieved up to 3.5 times speedup in throughput compared to the older methods, all while keeping the description quality competitive. It's a classic engineering trade-off. You get a massive boost in speed for a system that is still highly accurate.
And this isn't just an academic exercise. This kind of speed is critical for real-world applications. Imagine a self-driving car that needs to identify and understand a pedestrian, another car, and a traffic sign all at once in a split second. Or a navigation app for a visually impaired person that can instantly describe all the items on a grocery store shelf.
In any situation where an AI needs to perceive a complex, crowded scene and act on it quickly, this parallel approach could be a game changer. You're no longer stuck waiting for the AI to describe the world one object at a time.
So to sum it all up, today's AI models are slow at describing multiple things in an image because they do it sequentially, one by one.
This paper, PerceptionDLM, introduces a new method based on diffusion models that works in parallel. It generates all the descriptions simultaneously, like a team of artists working together.
And thanks to a clever trick involving blinders to prevent the AI from getting confused, it achieves a massive speedup while maintaining high quality. It's a huge step forward for creating AI that can perceive the rich detail of our world as quickly as we do. That's all for today's episode of Daily Papers. Join us next time as we unpack another piece of the future.